Yes, class, am I audible to all of you? Fia, Tarifia, in this batch you are here. Okay, Austin, Alia, Humam, Shahid. Am I audible to all of you?
Yes, miss.
All right. See, class, let us start with ray optics today. As I told you in the last class that we'll be starting with ray optics, but in today's class, we'll be discussing the very basics of it because some of you have texted me that you want the important questions from back of exercises of NCRT to be discussed. So I'll discuss those questions today itself so that now there won't be any interruption in ray optics class. So basics of ray optics, let us discuss. So at least ray optics is started. So initially, let me take few portions of ray optics today.
Ma'am, is this the first class?
Yes, Fia, this is the first class. Right now only,
Okay.
nothing has
Yeah,
been started.
Okay,
You
ma'am.
can stay in the class, this is the first class. So yes, I was saying, let's start with ray optics for 20 minutes, 30 minutes. Let us just start with the basics of ray optics. Then I'll discuss all the important questions. But see, class, one more thing I'll tell you. All those who are having difficulties with NCRT back exercises, most of the questions we have already discussed. Most of the questions that we have discussed are based upon the pattern of NCRT only. All right, like this time whatever questions we have discussed in the class. So it's just that some of the values here are different, some of the values there are different, like this. Most of the questions we have practiced, and some questions are there which are completely based upon the assertion reasoning type questions. So that also we have done it in the form of numerical. Still, I'll just go through once today also with all of you. If there is any question which I want to be discussed, that we'll do. If you're otherwise, specifically, you can send me the question also, but you will be able to manage. We'll discuss it today. So let us just start with the basics of ray optics from tomorrow onwards. Then, and if you people are having doubts today also, so you can share, because after this, I'll be starting with the doubt class or revision only. So if you people are still having doubts, like Tarif, we had an extra class also, doubt class. So still you people are having some doubts, you people can share your doubts on WhatsApp so that it easily gets clarified today itself. From tomorrow, book 2 starts, so at least you are thorough with first book. And if there is any topic also you people want me to repeat, you must have studied for your half yearly, your unit test. So if there is any topic which has been missed by you and you want me to repeat, so let me know that also today, because we can devote one class at least to this revision and all these things, doubt class and all. So if there is any topic you want me to repeat, just text me the name of the topic. I'll just revise it once. So other students will also have a revision for that. And specifically, if you people are having questions from any other textbook, that also you can share me on WhatsApp. Group is already there, share it on the group. Otherwise, text me personally. Like Tharif, what he did, he just clicked the pictures of all the questions. That is also fine. That is also perfect. Now, starting with ray optics. See, basics of ray optics, let us cover. Ray optics is the most important lesson from your book 2. A very, very important. You cannot leave ray optics for your final exams. Some lessons are there which can be escaped while revising, right? When some things are present, you can escape certain topics for revision. But this is one of the topics that cannot be neglected. Ray optics is one such a topic. If it's like, if you have removed ray optics from your syllabus, if you have removed ray optics from your preparation, you are not prepared for the board exams. From book 1, I cannot state one lesson, because your first chapter, second chapter, third chapter, fourth chapter, all of these are important. And the first 4 chapters are very important when we are talking about the first book, because that is the basic for your electromagnetism. See how chapter 5th, 6th, 7th, 8th, these quickly went, because they had the concepts which we already studied in the first 4 lessons, right? Whatever you have studied initially, that are only going to come. But now what we are going to start, this has no correlation with your electromagnetism. Electric field won't come. Now your magnetic field will come. All these things are not included now. So how we'll go about? We'll start with the basics of reflection. See, reflection is there, refraction is there, mirrors are present, lens are present. Then once we start with lens, then we go into the details of refraction and so on, like this. So what are all these processes? Whenever we are talking about ray optics, what are all these processes? See, whenever there is a surface, some processes occur on the surface whenever a light strikes. Now remember, the basic term that will be used throughout your ray optics, wave optics, dual nature, everywhere is the term light ray. Ray, you should know what is meant by ray when we say ray. Ray means it's a part of a light. The entire light which is running, when we are taking a part of the light, when a portion of light is striking, then we call it as the ray. Fine, that is known as the ray. Whenever you are having from a huge portion of light, you are having a small portion. So that is known as a ray. All right, so ray of light, ray of wave, these terms are going to be used commonly. So that's why I'm saying these terms, you all should be familiar now with these terms. All right. So ray of light, whenever it strikes an object, what all phenomena can occur? This should be your prime concern now in this lesson, because we'll start with reflection. So we'll be practicing the questions of reflection. That is easy. But once the lesson is over, we'll be having reflection also. You will be having refraction also. So it's you who has to identify which formula you have to use, because you will be having formula for mirror also, for lens also, and everything will look similar. I'm telling you, no concept of electromagnetism is there that you can relate with F is equal to QE and magnetic flux, electric flux, whatever we have been studying. Nothing. Everything is different over here. Waves and ray, waves is also different. Forget waves. Waves is also not a very difficult lesson. Waves also you'll be able to manage. Class, one thing I'll tell you. Today also, whatever we'll do, small portions only, whatever we'll do today and tomorrow. Every week, you should be prepared for ray optics. I'll ask questions before the class starts, because this is a lesson which has a lot of definitions also with the numerical values. So you people should be prepared for every class. And what about the EM waves table? Are you people thorough with that? Electromagnetic waves table and the diamagnetic, paramagnetic, ferromagnetic also I had shared. 2 tables I had shared, which I left on to you people, that you people have to revise it and learn it by yourself, because that was a portion which couldn't be memorized with my help, that you had to do. So are you people done? Are you people thorough with it? EM waves, what's the status? Should I ask questions and confirm them? Yes, no. At least update me. Are you people, have you people revised it? Have you all gone through the table? Because once I had discussed it, maximum frequency and on. You have, no? Okay, Austin has at least. Fine, I'll ask them questions towards the end of class. So see, yes, I was saying ray is a part of light. So when a ray of light strikes, how many phenomena can occur? Now see, one thing be sure whenever we are studying about ray optics, a perpendicular will always be existing, which we call as the normal. We call this as the normal. Normal means this is an imaginary line which is kept perpendicular to the plane. Normal term means what? What can you figure? If the term normal is given, angle should be 90 degree. Normal means only 90 degree. So this is normally made, means this is made 90 degrees to the plane. Now, whenever a light ray comes on the surface, whenever a light ray which was moving strikes a surface, because it's not necessary that every time it is striking an object, right? So whenever an object strikes a surface, this ray of light, because this is not a complete light, that's why we are using the term ray. Okay. So this which is striking is known as the incident ray. This is known as the incident ray. Incident ray strikes the material strikes the object, opaque object, transparent object, translucent object, any type of object. So the ray of light which is striking first, that is known as ray of light, incident ray. Now what happens to this incident ray? Remember, three processes can occur to this incident ray. First one is that this ray of light which has come can exactly be rebounded back, bounced back. That phenomena with the help of which this ray of light goes back, that process is known as process of reflection. This entire process, this is called, this first process which is possible, this is known as reflection. Reflection. So this ray of light which came onto the surface and which is now bouncing back, this is called as the reflected ray. So incident ray now gets converted into a reflected ray. And why again reflected ray? Because this is not the entire light. This is just a part of the light, right? So first phenomena is reflection which can occur. Second thing is that which is not visible to all of us, but it is occurring. Incident ray is coming, but neither incident ray is leaving, nor we are also able to experience the incident ray. So what has happened? Incident ray came, that we are sure that the incident ray came, but we are not able to see the reflected light. We are not able to see the incident ray coming from the backside also. So what is the possibility? What has happened to the incident ray? Anyone who can say?
It has been absorbed completely, ma'am.
It has been absorbed completely. So second process that is possible is absorption. Why are we not able to see? Because the material is such kind that has absorbed that particular ray. Very good, Fia. So this is absorption. And among absorption, if class 11th, this was a part of your syllabus in thermal physics regarding black bodies, black body radiation and all. So the best absorption is actually done by black body, because they have the capacity to completely absorb all the light, not for a particular frequency, for all the light. That's why we call these black bodies to be perfectly absorbing materials. So absorption can occur. Incident ray came, material has completely absorbed the light into it, no reflection, nothing. Last phenomena, which I had already mentioned to all of you, that see, if this incident ray was coming, had there not been any surface, this incident ray would have gone straight like this, right, into the path. But instead of going like this, if this moves somewhat deviated, so this is the third phenomena which can occur, which is refraction. And the ray of light is known as this is known as the refracted ray. This is known as the refracted ray. So refraction can occur. Now see class, in class 11th, you had absorption. Thermal physics mein, you had absorption. This topic was there in your second book. Right now in class 11th, you will be just focusing on reflection and refraction. Any other, see, this lesson is actually lengthy. It will take a little time. This is not, lots of topics are there. Refraction is there. Then based upon refraction, you have depth, total internal rotation, lens. Then after, once you think the entire syllabus is completed, then again we are left with optical instruments. So this is a lengthy lesson. So go with the lesson. Do not make this at least like. Do not pile up your syllabus for coverage, at least for ray optics, I'll suggest. Okay, write down this. Class, I think let us discuss the questions of NCERT, which I was mentioning to you. Then after the questions of NCERT, if you people have doubts on any topic, or meanwhile also you can let me know. So first write down the question, take 2 minutes, try it yourself and send me the answer. Then I'll discuss it. See class, in this question, it says that in a certain region of space, electric field is along the z direction throughout. The magnitude of electric field is, however, not constant but increases uniformly along the positive z axis at the rate 10 to the power 5. Force we have to find out, torque we have to find out, dipole moment is given in the negative z direction. See how it will look on the graph. If this is z axis, x axis, y axis, see direction of electric field is here towards the positive x axis. Dipole moment will be along the negative z axis. So this is dipole moment. Here one charge will be there, here another charge will be. So plus q minus q. Like this we'll have the figure, right? Now see, when the electric field is changing in the direction, I have told you we have done a partial differentiation also that time. See, when we are differentiating electric field over the z-axis, this is 10 to the power 5 Newton per coulomb meter is given, right? Newton per coulomb per meter actually, this is given. When you are differentiating the same, because whenever you are taking electric fields change along y-axis or x-axis, this is equal to 0. Because there is no change across this electric field is not present. So what change you will be having? No change is there, right? So, and one more thing, again regarding dipole moment also same thing. Dipole moment when you are taking across the z-axis, that is 10 to the power minus 7 coulomb meter. But dipole moment across x-axis is 0, dipole moment across y-axis is 0. Now, class, one thing, when we are calculating, this is dipole moment. See, when we are calculating the electric force on a dipole. Now, how will we do it? See, force, when you are calculating the force on a dipole, F is equal to electric field we had dipole moment also. When we are calculating force, rate of change of electric field into the momentum that into the dipole moment that has been covered. So what will be the force? You will multiply electric field with the dipole moment, right? PE we will take it. So when you are writing it, so force will be PX with differentiation of EX or whichever it is changing. This will be 0 in any ways. Again, if you will take dipole moment across y-axis with electric field change across y-axis, this will also be 0. But ultimately, you have the values for z-axis, right? So this will be 0, this will be 0. You have the values across z-axis. So you will be getting the force. Force is 10 to the power minus 7 into 10 to the power 10 to the power 5, right? So this becomes 10 to the power minus 2 Newton. This is the force. Now this is along negative z-axis. So either you can write minus and then put k cap, or you can even keep it and write the full definition. But when we are talking about torque, see, this was force, so we kept it. When we are talking about torque, P E sine theta, what is the angle over here? Dipole moment and electric field are acting exactly opposite to each other. So the angle between them is 180 degree. So torque will directly be 0 without any calculations. This was a good question which I found in NCERT chapter 1, which we hadn't discussed. So write it down. Though the formula usage was same, it's just that you have to know how to make up the figure. Question you people have written, or somebody is writing the question? I'm scrolling it through the solution. If someone has not written the question, let me know and scroll up it. Now, from potential, let us see some questions.
Ma'am, this is from which chapter?
first chapter.
Okay, ma'am.
Yes, Tarif, your answer is right. Any other answer? See, if one of the 2 electrons of H2 molecule is removed, we get hydrogen molecular ion, which is H2 plus. In the ground state of an H2 plus ion, the 2 protons are separated by roughly 1.5 angstrom. Okay, electron is roughly 1 angstrom from each proton. So proton is 1.5 and proton electron is 1 angstrom. Okay. So we have to determine the potential energy of the system. See, it's like this is electron. Suppose here we have electron, here we are having proton. This separation is 1.5 angstrom. This separation is 1 angstrom. This is what is given in the question, and we have to find out the potential energy. In potential energy, one more thing that we have to keep in mind is the charge. This will be E. This will be minus E. These two will be plus E plus E. So potential, basically the diagram was there in this question. Otherwise, this question is not difficult. You just have to write down the formula. What is potential energy whenever you write? This is K Q1 Q2 divided by R. So K Q1 Q2 divided by R, that will be the formula of potential energy. So when you are calculating the entire system, one charge is this, one charge is this. So the separation will be 1 angstrom. Then their separation will be 1 angstrom. Then these two charges, then their separation will be 1.5 angstrom. So net potential energy first will be Q E. Second one is minus E divided by 1 angstrom. Right? 1 angstrom we can write.
Yes, ma'am.
10 to the power minus 10 we can separate. Yes. Again plus K E into minus E, same 1 angstrom. Second one will be K E into E 1.5 angstrom. So let us take K E square common, right? K E square 10 to the power minus 10 because 1 angstrom is equal to 10 to the power minus 10 meters. Okay, so from here we are left with minus 1. From here minus 1. From here plus 1 by 1.5. Right, 1 by 1.5. So we just have to calculate now. This is our answer. We just have to calculate it. See, this will be E square. This is K, 9 into 10 to the power 9. Then E square, that is 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 divided by, this is 10 to the power minus 10. No units are specified, no? Determine the potential energy of the system. So Tarif, how are you getting it and why did you calculate it in electron volts? It wasn't mentioned to calculate in electron volts. Specific reason? Anyways, this becomes in minus 4 by 3. This much of joules is your answer. Just check, someone check. Let me know what's the answer coming. 19.2 is fine, Tarif. But why did you calculate it in electron volts? This and this will be cancelled. 1.6 will be divided. Okay, write it down. Write down the solution. Yes, class answers. Is it 19.2 only? Just confirm the answer once. And those who have done this, you people can start leaving now tomorrow, because doubts you haven't shared. I have checked the WhatsApp right now also. You people haven't shared any doubts. So straight away, we'll start with laws of reflection tomorrow. So I think doubt session for first book is not needed now. If you people have any doubts, please then text me again, the way you have texted for NCERT questions. Now we'll start directly with